Hello and welcome to another 5-minute masterclass. Today's topic is converting mixed and improper fractions. So before we even get into conversions, we need to remember what they are. So an improper fraction has that numerator that is bigger than the denominator. So they're sometimes referred to as top-heavy fractions. The number at the top is bigger than the bottom. So for example, 25 over 7 or 22 over 8. So 25 sevenths and 22 eighths. Our numerator, the 25 and the 22, are larger than the denominator, the 7 and the 8 respectively. Now a mixed number has a whole part and a fractional part. So for example, we've got 3 3/4 or 2 5/8. So I've got that whole part, that 3 and the 2, and then a fractional part, the 3/4 and the 5/8 respectively. Now improper fractions and mixed numbers are two different but equivalent ways of showing the same amount. So when we're converting, we're not changing the value, we're just changing how we present it. So I'm going to start by converting mixed numbers to an improper fraction. So I've got 2 3/4 and I want to change it to an improper fraction. Now what isn't changing is my denominator. I'm not changing the value, I'm not changing the size of my fraction here. So I can complete my denominator straight away. It's going to be quarters. We've just got to consider how many of them. Now there's 2 whole ones are telling me I have 2 whole things split into quarters, and I'm going to just draw a diagram to support myself, and I know they're not equal, but just go with it. So I've got a whole one there and I've got another whole one here. I've split them into quarters because that's what my denominator is saying. Each whole one has been split into 4 parts. So I've got 2 whole ones, and then I've also got another 3/4. Okay, so I've got my 2 whole ones and 3/4 left over. So when I consider how many quarters I have, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 quarters. I'm going to do the same down here with 3 5/8. So I've got 3 whole ones. So here's my one. Got another one. And then I'm splitting them into 8s. I've got a third one. And then I've got 5/8 as well. So there's 4 and a fifth one. So when I add all of these together, I know we're still in 8s. My denominator's not changing. But I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. I've got 29 eighths. Now it's all well and good drawing a diagram each time, but as I say a lot, mathematicians are lazy and we want a speedier way of answering this question. So what we can consider is how we can speed this part up, that whole part. So I know I've got 4 in a whole one, 4 in the other whole one, so I've got 8 all together as part of my whole. And a quicker way of finding that 8 is to do 2 times 4. So by multiplying my denominator by the whole number, I can tell you how many quarters are in the whole part. And then what I just need to do is add on the fractional part. So I just need to add on this 3. 2 times 4 is 8. Add on the 3, gives me an answer of 11. Show you again that shortcut for this one here. So we know the answer is 29 eighths, but a speedier way to calculate it is to multiply my denominator by the whole part. That's going to tell me how many eighths are in the 3 whole ones down here. And then I need to add on this extra, add on the 5/8. So 8 times 3 is 24. Add the 5, gives me an answer of 29. And so I've got 29 eighths. Now the other conversion we have to do is we need to work backwards. We need to say, okay, I've got 10 thirds. How many wholes is there to put that in? Now the same is true. The denominator is the same. So I know my answer is going to have thirds in it. We just need to consider how many whole ones and what parts are left over. Now again, I can draw a diagram to illustrate that. If I've got a whole one and I split it into thirds, well that's 3. Got another whole one. I can split that into thirds. Well, that's 6. I've got another one. I'll draw it up here. Whole one. If I split that into thirds, that's 9. That's still not enough. So I've got another whole one down here. Now that's too many, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I only actually need 10 of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I can see from this diagram, that means I've got 3 whole ones and I've got 1 left over. 3 whole ones and a third. And I can do the same with this other diagram. Here I've got 14 fifths. I know my denominator is saying fifths. So I'm just going to draw a diagram split into 5. 1, 2, 3, 4, 5. I'm going to keep going until I can get 14. So that's 10. Draw another one. Now that's 15, that's too many. So I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So when I'm counting how many whole ones here, well, 2 whole ones have been used. Not quite the third one, I've got a bit left over. I've got 1, 2, 3, 4 fifths remaining. Now again, that's just drawing a diagram and it's perfectly acceptable in an exam to draw a diagram, but you might choose to have a shortcut. And at that point we need to consider, well, what does this fraction mean? 10 thirds. It's another way of saying I can do 10 divided by 3. Now 10 divided by 3 goes in 3 times, but there's a bit left over, there's a remainder, remains a 1. And this can help me write my fraction. 3 remainder 1, because I've got 3 whole ones and I've got 1 part left over. 1 what? Well, 1 third, it's not changed. So look, 3 whole ones and 1 third. Do the same for this final example down here, there's 14 fifths. If I was to do 14 divided by 5, I'd have 2 whole ones and there'd be a remainder of 4. So that means I've got 2 whole ones, 4 remainders, 4 what? Well, it's 4 fifths because our denominator doesn't change. Okay, over to you. Pause the video and try these questions. I've started you off for a few of them. When you're ready, press play. Mark your work. I'm sure you've been very successful. But if you need further practice, we've got Sparks, Corbett Maths and Maths Genie. Follow the instructions for further work. Thank you for your time today and I'll see you again for another 5-minute masterclass.